All right, so we're going to look at adding and subtracting polynomials here. So a polynomial is just any of those algebraic expressions with one or more terms. So if you recall, an algebraic expression is a sequence of x's and numbers and variables that are added together or subtracted, and they make up they're made up of terms, and terms again are the components that are the multiplication portion. So 3 or 3 times x or x squared or just x, and so we can have one or more terms to create a polynomial. So there's 3 specific polynomials that we tend to name. These are the monomial, mono meaning one, so one term. So examples of this could be something like x, 3, negative 4, negative x squared, 5x, 3y. Those would be examples of monomials. There's a single term there, and nothing's separated by the plus or minus sign. There's a minus sign here, but it's not separating them. Again, these commas mean they're separate, complete entities. A binomial, some examples of a binomial. So bi meaning two, bicycle, 2 wheels, binomial, 2 terms. You could see something like x plus 3, or maybe 4x squared minus 7x, or 2x minus 6. These would be examples of binomials. Just for a negative one, we could have negative 4x cubed minus 16. Again, all examples of binomials. There's 2 terms, 1 term, 2 terms, and it's separated by the plus or minus sign. 1 term, there's the multiplication making that a term, multiplication making that a term, separated by a minus sign. So we have 2 terms in each of these. And then a trinomial, using that same process. Tri meaning 3, like a tricycle, 3 terms. So we have something maybe like x squared plus 4x minus 7, or we might have 16x squared minus 16x minus 16, something like that. Separate terms, and again the terms are separated by the plus or minus sign. So these are examples of trinomials. So now, when we're working with these terms, we have the concept of a like term. So terms that are alike, that are have a similar variable and exponent. So the variable portion and the exponent portion have to be the same, so we can add, or when we get to the point of adding or subtracting them. So they have to be these like terms. So ones we're common and familiar with adding and subtracting: numbers like 3, 4, negative 6, 3.14, 1/2, 0.6. We've added, subtracted numbers like these. These were the numbers we learned how to add and subtract throughout our time. So you could have something like 3 and 4 added together because they're the same terms. Now, some other examples of like terms would be x and negative x, 2x, negative 3x, 1/2 x, 0.5x. These are all like terms. They all have an x, and the power on the x is the same. This is 1x, this is negative 1x. Again, recall that if you have a letter and there's no number with it, that it's one of them. If I have 1 pencil on the page here, or I have a pencil, both mean the same thing. I have an x, or I have 1x. So that lack of number in front is just assumed as a 1. Some other examples of like terms could be x squared, negative x squared, 3x squared. These are like terms because they all have an x squared. The variable and the exponent portions are exactly the same. So there's an x squared, there's an x squared, there's an x squared. And another case that I want to look at is when they're not. So these are all like terms. Each line is a set of like terms. Now, in the case of something like x squared and 4x, well, they both have an x in them, but they're not like terms because the exponent portion is not the same. So the exponent is not the same on them, so these are not like. And again, note these are three separate sets. But these two are not like terms. 3 and 3x are not like. They have a number in both of them, and it happens to be the same, but that the number being the same doesn't matter, it's that they have a number. But one has an x and one doesn't. So these are not like terms. They have to have the same numbers, so they either have to have numbers, or if they have letters, the letter and the exponent on the letter has to be the same. These all don't have an exponent written with the letter, so they're all the same. These all have a power of 2 with them, so they're the same. This has a power of 2, this doesn't, so they're not the same. This has an x, this one doesn't, they're not the same, they're not like terms. So we can only add the ones that have the like terms. So look at some examples of doing that. Again, we're only adding the like terms, and we only add the number part. So if you think about adding these, I have 2 pens right here, and then I have another pen I'm going to add. So I have 1, 2, 3 pens. And this is important to remember because later on when we get to multiplication, people start often confusing, well, I add the number and I add the letters. You're not adding, you're adding the number of items. So in the case here, remembering back to the last lesson where we said x could represent a line, we have 3 lines of length x plus another 2 lines of length x. So this here, what we do is we just add the numbers. They're like terms. They both have an x, so and there's no exponent on it, so they're like terms. So 3 plus 2 is 5x. And visually, what that would look like is 1, 2, 3 lines, and we'll say that they're x long, plus another 1, 2 lines that are x long. So each of these lines have a length of x, so we have a total of 5 lines of length x. In the next case, we have 4x squared plus 7x squared. So again, we have a like term because they both have an x to the power of 2. Again, the exponent has to be the same. So we can add these. And again, we just worry about the numbers. It's 4 plus 7, which is going to give me, and I was going to rewrite the 4, that's 11x squared. And again, visually, what you should be looking at here is 1, 2, 3, 4 squares. Remember, x is a square. When we think about x, what we have is a square. We have 4 squares, and we're adding another 3, 4, 5, 6, 7. So these are 4 squares plus another 7 squares. We're adding those together, so we have a total of 11 of these squares that we call x's. Now in the last example, we don't have, we have 3 terms now. And if we look, 3x and 4x are like terms. The 1 is not. So we can add 3x and 4x, but we can't add the 1. So here's how that goes. 3x and 4x we can add. 3 plus 4 is 7x plus a 1. And that's it. 7x plus 1. We just leave the 1 there by itself. It hasn't changed or anything, but we've combined these two like terms into 7x. Now, if we take a look at some subtraction and working with some negative signs, again, you're only subtracting the like terms, you're only subtracting the number part, and you're treating it the same as you would the addition in a general sense. So in the case of 7x squared minus 4x squared, we just worry about the numbers. We have 7 boxes, we have 7 squares, and we're taking away 4 of those same squares. So we're left with 7 minus 4, or 3x squared. We're left with 3 of the squares. Here, again, we have like terms, 6x and 10x. They both have an x. The x has the same power, which is a 1 or not showing. So we have 6 minus 10. 6 minus 10 is negative 4x. So we just worry about the number portion, and then the variable portion stays the same. Now here's a bigger one. We got a few more terms. It's 6 terms in there, and we have some like terms. Now when you have something bigger like this, there's 2 methods that you could use to work with this. You could, 1, rearrange it and rewrite it so that you put all the pairs of like terms together, or you can just make sure that you go through step by step, crossing off the ones that you use. And so I'll show you that method, because I think that one is a little nicer and less likely to make an error in my thought process. So we'll start with our negative 4x squared, and then we have negative 6x. The sign in front of the number sticks with it. So we have negative 4x squared and negative 6x squared. Those are like terms. Negative 4 and negative 6, well, that's negative 10x squared. So there's our first pair. Cross them off. Now, the next pair that I see, I have a negative 7, so circle that one, and a negative 4. Those are like the next pair, only pair of like terms. Negative 7 minus 4 is going to give me negative 11. And then finally, I'll cross those off because I use them. Finally, I have this, and I'll make a triangle around them. You could use different colors. You don't have to do this once you get comfortable with working with these like terms and that. But I find using different shapes or different colors helps me make sure that I'm getting them all. So I have this last pair here. I have 2x and minus 2x. So positive 2 and negative 2 would end up being 0 x's. So we write that down. Now, we can simplify this, because if you think about it, if I have my 3 pens and I take away 3 pens, there's nothing left. They're all gone. So I don't have to write the plus 0x. I could just write negative 10x squared minus 11. You would not get marked wrong if you put the plus 0x. It is correct. However, it's not needed. And if you're later on using these in when you get especially to grade 10 and things like that, it's easier to work with it when you just get rid of that value in its entirety. So here we have our final result, negative 10x squared minus 11. Now the only other thing that comes up when we're working with adding and subtracting polynomials is brackets. They are used in a lot of questions to help organize pieces, or if we have 2 separate things and distinct things that we're adding together. So there's 2 things to note. If there is nothing in front of the brackets, you just get rid of them. And so if we look at this example here, there's nothing in front of the brackets. Okay, this set of brackets, this is considered in front of it. So there's nothing in front of the brackets here, so we can just get rid of them. In this case, there is something in front of the brackets. There's a plus in front of the brackets. So in that case, if there's a plus or minus sign in front of the brackets, multiply each term by plus or minus 1. So in this case, by plus 1. So what that means, nothing in front, get rid of the brackets. 2x squared plus 4x minus 1. Brackets are gone. There was nothing to do. Here, we have to multiply each term in the brackets, all 3, okay, by plus 1. Now, multiplying by plus 1 doesn't change any of the signs or anything. So we're just left with negative 7 times plus 1, which is negative 7, x squared. Positive 4 times plus 1, positive 4x. And negative 3 times plus 1, which is going to be negative 3. Now, you might pick up the pattern that if there's a plus, none of the signs change. We just basically get rid of the plus and drop the brackets. And if you can remember that, that's okay. But if you don't, always remember, you just multiply by plus 1 in this case, if there's a plus sign. If it's a minus sign, like in the next one, we'll multiply by -1. So now we can simplify our and collect our like terms here. So I have 2x squared and -7x. So when I combine this together, I get -5x squared. 2 minus 7. And again, the x squared just stays. So those are done. The next one, I got 4 plus 4x. I got another plus 4x over here. So that's going to give me plus 8x. Done with my x's. And then finally, I have a plus or a -1 and a -3. That's going to give me -4. Cross those off. Everything's crossed off. I've covered all my numbers. And there is my equation simplified down. In the next example, I have a minus sign here. So in the first set of brackets, I can get rid of the brackets because there's nothing out front. 6x squared plus 2x minus 3. But here there is a negative. So I got to multiply everything inside by -1. And I like drawing these arrows, and these are useful. We'll use these in the next section when we're doing multiplication as well. They help just keep track and make sure we get everything covered. So now we're multiplying each term by -1. So positive x squared times -1 is going to be -1x. Or -1 times -4x. Two negatives make a positive. And then -1 times +3 is going to give me -3. If you notice, all the signs just flipped. This became negative, this became positive, this became negative. The 1 didn't have to be written there, but I wrote it because I felt it illustrated the multiplication by the -1. So now we can collect our like terms. And sorry, that should have been a squared. Now we can collect our like terms. So I have 6x squared, -1x squared. That's going to give me 5x squared. Done with the x squareds. Next up is a 2x. So plus 2x. Or sorry, I want to calculate that first. I got a plus 2x and a plus 4x. So that's going to give me a plus 6x. And then finally, I got a -3 and a -3. So -3 minus 3 is going to give me -6. Done with those. 5x squared plus 6x minus 6 is the simplification of that one. And finally, the same process works if you got 3 terms. Or 3 polynomials here. So I got polynomial, polynomial, polynomial. Again, same process. Drop the brackets because there's nothing out front. Multiply each of these by -1. So I'm going to get -4x squared plus 3. Two negatives make a positive. And then the last one here, I'm going to multiply everything by +1. So I'm just going to stay the same with 2x squared minus 2. And now I collect my like terms. Here's a pair of like terms here. 6x squared minus 4x squared is going to give me 2x squared. Oh, missed one. So do be careful. That's why we want to go through the whole line here. I got one more at the end. So 6x squared minus 4x squared is 2x squared. 2x squared minus 2x squared is 0x squared. Next I have a 7x. Cross those ones out. There's no other x's, so I just write down the 7x. Done with that. And then I have a +3 and a -2, which is going to leave me with +1. Again, we don't need to put the 0x squared there, so we could just write 7x plus 1, and that one's done. So again, remember, like terms are going to have the same variable and the same exponent, or they're just a plain old number. You can only add like terms to each other. You cannot add an x squared to an x. If you have a set of brackets, then if there's nothing in front, like the first one, you just get rid of the brackets. If there's a positive in front, you multiply everything by +1. If there's a negative in front, you multiply everything by -1, which will, in the first case, keep the signs the same. In the second case, it'll switch all the signs to their opposite values. All right, that's about it for this one.